So for the rest of this one, let's see. So we need to figure out which of the following represents the volume of the can in terms of the height h. So we need to start with a volume of a can, and that's the V equals pi r squared h. Because it says these words in terms of h, that means they want only h to be the variable in this formula. So there's an r and an h. We need to get rid of the r. So we need to replace the r with something but in terms of h. Okay, so let's see. What we can do is use the first sentence. It says something about h. It says the height of a cylinder can is equal to its diameter. So that's telling me that height equals the diameter. Diameter, you have to remember, is equal to, well, the diameter is the distance all the way across the top of the circle, but it has to go through the center. Well, a radius is half the diameter, so a diameter contains 2 radii, so it's going to have 2 r's. Okay, so we need to use that idea. So when I solve for, so I'm going to have h equals 2r pretty much. The height is equal to 2 radii because the height is the same as the diameter. We need to solve for r because we're going to replace r with whatever we get. So to solve for r, I need to isolate the r, which means that I got to get rid of that 2. So I have to divide both sides by 2. So that means that r is going to equal h over 2. Okay, so now we could take this and replace the r with h over 2. But remember, this is a pi r squared, so we're going to replace r with an h over 2, but we're going to have to square it. So let's see, we're going to get v equals pi times h over 2 quantity squared times h. So remember, when something is being squared, especially a fraction, we need to make sure that we not only square the numerator, but we also have to square the denominator. So in a sense, we're thinking of this as being similar to the distributive property, and it is. So we're going to have pi times, I'll still use parentheses for times, h squared is h squared, 2 squared is 4 times h, okay? So when I clean that up even more, well, you can make anything a fraction by putting it over 1. So we can put that h over 1, and then we're going to get pi times h squared times h is a pi h cubed, and then 4 times 1 is a 4. So all we have is a 4 in the denominator. So pi h cubed over 4 is the expression that we're going to use for the volume of the can in terms of the height, which means the answer is D. Number 9, it says the volume of a rectangular box is given by the function v of w equals 36 minus 4w times w squared. What is a reasonable domain for the function of this situation? And you guys got to recall the last quiz that we did with the postal box situation. It was our last partner quiz that we did, which, by the way, you can still do retakes on. But you have to come in for tutoring on that. You have to correct the ones that you did originally. Okay? So what we need to do is to find a reasonable domain. That means we need to find the zeros, because the zeros are x-intercepts, and the x-intercepts are going to tell us what values we're using on the x-axis. Well, in this case, w is our x. Okay, they're using a w, but it's the same thing. It's the x-axis. So to find the zeros, we need to set the equation equal to 0. And what's nice about this one is that it's already in factored form. So all we have to do from here is split apart those factors and set them each equal to what? 0. So 36 minus 4w equals 0, and w squared equals 0. Let's start with the w squared. We know that when we undo something that is squared, we have to square root it. But the square root of 0 is 0. So there's my first n number, so 0. So we know that the lowest we're going to go is a 0, plus, guys, w stands for width. Is a width going to be negative? No. Width is never negative. They're only positive numbers. So it can't be A, it can't be B. It's got to be C or D. And so we know that when we solve for w over here, it must be what number? It must be 9. So let's go ahead and do it. We're going to add the 4w to the other side, so we'll get 36 is equal to 4w. And then we have to divide both sides by 4, and 36 divided by 4 is 9. So we do get these n numbers. Well, what's the difference between C and D? Well, that's the or equal to bar. Here, it's strictly less than. Here we have less than or equal to. Well, the or equal to is what's wrong. These are the zeros of the function. So when the width is 0, the volume is 0. When the width is 9, the volume is 0. Well, volume of a box can't be 0. These are just our boundary numbers, but they don't, we can't equal them. We can't equal them because it doesn't make sense for the volume of a box to be 0. So it will never be or equal to for this type of situation. These are just our boundaries. So it's gotta be C. So I hope you guys can remember that. These numbers just give us our boundaries. Okay. All right, number 10, it says, which of the following graphs shows a cubic function with 2 distinct zeros? So we've got a couple different things here. The first clue is we've got a cubic function. So that means we're dealing with an odd degree function. So we know it should have opposite end behaviors. It's got to go through the x-axis 2 times. 2 distinct zeros means it crosses the x twice. So 2 crossings. Well, we can see right away that letter A is an even degree function because both ends are going in the same direction. They're both going down. So this is not it, because that's even. B is opposite end behaviors, C is opposite end behaviors, D is opposite end behaviors. Okay, so now let's look for 2 distinct zeros. B is only crossing through once, so this only has 1 0. I need 2 though, so it's not B. C has 2 zeros. Okay, so this one's a possibility. Let's look at D. D has 1, 2, 3 zeros. Oh, it has too many. So it's not D, it's gotta be C. And I'll just highlight it right here. So C was the correct answer to number 10. All right. Number 11, end behavior. It says, which statement accurately describes the end behavior of the graph of a polynomial of, it's saying even degree, okay, so we know it's even, and with a negative leading coefficient. So it's an even negative. So even degrees have the end behaviors going in the same direction. But because it's negative, that means that direction is down on the left and down on the right. Remember, down means negative infinity, okay? So as x goes to each of the infinities, left would be negative infinity, right would be positive infinity. The y, the f of x, is always going down, so negative infinity on both sides. So I'm looking for basically f of x, because f of x is y, going to negative infinity on both ends. So I'm looking at just the f of x. This one shows down on both ends, so A is it. B says down on the left, but up on the right. C says up on the left and down on the right. D says both going up, because both of those are positive infinity. But I need both going down, so A was it. So remember, x approaching an infinity, that's your left or your right. F of x approaching an infinity, that's your up or down. But here, the x will always be both. X approaches negative infinity, x approaches positive infinity. The f of x is where you could tell the direction up or down. That's what we need to see. Okay, we needed both ends going down, so just look for f of x approaching negative infinity on both sides. All right, number 12, it says, classify each polynomial function in the table as even, odd, or neither. You had a problem like this in your warm-up today. So let's see. The first one, f of x is equal to 8x. Well, when there's no exponent on a variable, we assume it to be a 1. 1 is an odd number. So that one's odd. G of x, we have x to the 8th. 8 is an even power. And we have a plus 1. Remember, a constant has an x to the 0 power on it, and 0 is an even number. So both of these terms have a zero, or not a zero, even degree. So because all terms have even degrees, this is an even function. For h of x, we have 3x. Remember, when it's just an x, it has a power of 1 on it, so that's odd. But the 5 is a constant which has an x to the 0 power on it, and 0 is even. We have a mix of odd and even degree terms. It's got to be purely one or the other, so this one's a neither. R of x, 5x squared minus 3, well, that power of 2 is an even degree. And then on that constant, it has an x to the 0 power. 0 is an even degree also. So this one is purely even. And then we have v of x equals 8x to the 5th plus 2x cubed. The power of 5 and power of 3 are both odd, so this one is purely an odd function. And then w of x, power of 2, power of 1. And whenever we have a constant that has a power of 0, well, 2 and 0 are even degrees, but 1 is an odd degree. We've got a mix. So this one's a neither. It's got to be all or nothing. So it went odd, even, neither, even, odd, neither. All right. Number 13, Mark used synthetic division to divide the polynomial by another polynomial. I won't read it. You guys can see that for yourself. His solution, though, is incorrect. He's wrong. Mark's work is shown below. So Mark used synthetic division, and he got it wrong. So we need to figure out where Mark's first mistake was and how should he correct it. So remember, this is synthetic division. So you first start with, oops, not right here, what you're dividing by. It's an x plus 2, but remember, you have to set that equal to 0 and solve, so x equals negative 2. Okay, so negative 2 should be in the corner box, and yeah, there is a negative 2 in that corner box, so far so good. And then the coefficients of the problem. So the coefficients would be a 1, I see a 1, 2, negative 5. There's no x term, so we have to hold its place with a 0, and then a constant of 9. So he's got all the setup good. So now let's see if he did the synthetic division correctly. Obviously he didn't, so we need to figure out where did he go wrong. So here we go. We always drop down that first number, and then we multiply. 1 times negative 2 is negative 2. 2 minus 2 is not 4. It should be 0. There is the mistake. So the mistake is happening in column C, row 3. So column C, row 3 should be 0. That is letter B. So B is the correct answer to number 13. All right. Number 14, which of the following terms in the binomial expansion of 1 minus 2x to the 8th power, which of the following are terms in the binomial expansion of 1 minus 2x to the 8th power? Select all that apply. Anytime you guys see these words, more than one option is correct. That doesn't mean select them all. That will get you 0 points if you do that. So don't do that. It will never be all of the options. But we need to select the ones that do apply to this. So remember, our clues. If it's to the 8th power, how many terms does this have? It's always one more than the degree. So there should be 9 terms. So remember to do your blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got my 9 blanks. Let's zoom out a little bit. Okay. And then our first term, well, we need the coefficients. So there's 2 ways that you could go. You could do Pascal's triangle, or you could do the 9 choose 0, 9 choose 1, 9 choose 2. Whatever is easier for you. A lot of you guys have been using Pascal's triangle, and honestly, that's usually what I use anyway. But you could use your calculator for the combinations. So I just need the row that starts with an 8 after the 1. So almost there. 15 and 6 is what? 21, 35, 21, and then 1, 8. That would be 28, and then 56, 70, 56, 28, 8, and 1. So this is the row that I need, because that's the one that has 9 terms. So 1, 8, 20, 8, 56, 70, 56, 28, 8, and 1. So I know what my coefficients are, and I can write them in. Okay. Then I need my first term. So the first term is a 1, and it needs to start at the highest power. So that's a 1 to the 8th. Well, 1 to the 8th is still 1. 1 to the 7th is still 1. 1 to the 6th is still 1. So it's still 1 no matter what. So I'm not going to write times 1 because it's not going to change any of these numbers. Okay, so then the next term is a negative 2x. You have to carry the negative with it. And remember, we start at the highest power on the very end. So I should have a negative 2x to the 8th power on the end there, and then negative 2x to the 7th. You need to put parentheses around that negative 2x, because when, oops, to the 6th power. Because when you raise it to these powers, you have to take into account that negative 2 also, not just the x. Negative 2x to the 3rd, negative 2x squared, negative 2x, and then anything to the 0 power is 1, so it's just going to be a 1. Okay, so 1 is the first term, but if you look at your answer options, none of these are a 1, so we're not talking about the first term. The second term, let's see what this ends up being, because that's going to have an x in it. So let's see if it ends up being negative 16x, and 8 times negative 2x is negative 16x, so yeah, that's one of them. Okay, we found one. All right, let's look at the next term with the x squared, because I do have an x squared on my list. I want to check that one next. But we have to remember, we have to distribute that power of 2 to not just the x, but also a negative 2. So negative 2 squared is negative 2 times negative 2, which is 4. 28 times 4 is 112. So this should be 112x squared. Is that what we have there? No, this is not an option then. Okay, all right, and then the next term, let's see, we don't have any cubic, so I don't need to check this one, so be smarter, work smarter, not harder, so we don't need to check that one. We do need to check an x to the 4th, so I do need to check this one though. Okay, so I'm going to have negative 2x to the 4th power. We have to distribute that power of 4 on the negative 2 and on the x. So negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. So that's a 16x to the 4th. So 70 times 16 is 1,120. So 1120x to the 4th. Is that what that says? Nope. So that ain't it either. Okay, so then the next one we have is, let's see, I need to see the 5th power. I need to see if it's going to be this negative number in front of that x to the 5th. So we have to distribute that power of 5 on the 2 and on the x. So let me show you how to do that in your calculator. You need to put parentheses around anything that's negative, so negative 2, raise it to the 5th power. It should be a negative number because it's to an odd power. And that negative 32 needs to be multiplied by 56. So this is going to be a negative number, and it is negative 1792x to the 5th power. And that is exactly what this shows. So check. Okay. And then we need to check the 6th power now. So we need to distribute this power of 6 to the negative 2 and to the x. So a negative number squared, or not squared, to the 6th power. 6 is an even number. This should be a positive number. But if you don't believe me, you can, oops, I need parentheses around both sides. You can raise it to the 6th power, but you have to use parentheses in your calculator. Otherwise, it's going to say that it's negative. And equals, and then times 28, and I'm getting 1792. So that would be 1792x to the 6. Is that what we have listed there? Yes, it is. So check. And then we just need to check the x to the 7th term. So 8 times negative 2x to the 7th. So negative 2 is being raised to an odd power. So that means it should be negative, and it is. And we have to multiply that by 8. And we're getting negative 1,024. So this one is negative 1024x to the 7th. Is that what it says? And no. So it's just those 3 options. Okay, so this one, and this one. And that was number 14. number 15, which of the following is the complete factorization of 6x cubed minus 9x squared minus 15x? All right, so we've got to factor. This is more recent information that we've been doing over the last few days. So first of all, the first thing that you should check for is a GCF, a greatest common factor. And we do have a GCF here. It is a 3x. So when we factor out that 3x, we're going to have 2x squared minus 3x minus 5. Okay? But inside the parentheses, we have a hard trinomial because the leading coefficient is bigger than 1. It's a 2. So we're going to need to do product sum, but we have to do the whole replacement thing and make 4 terms because it's a hard trinomial. So the product is a times c, and so that would be 2 times negative 5, which is negative 10. The sum is the b, so negative 3, and I need 2 numbers that multiply to negative 10 and add up to negative 3. Well, that's going to be a negative 5 times 2, because that multiplies to negative 10. Negative 5 plus 2 equals negative 3. So these are the droids I'm looking for. But I have to do the whole replacement thing. We have to replace the middle term with the new numbers. So instead of a negative 3x, we're going to put negative 5x plus 2x, and we're going to get our 4 terms. So we're going to have, we'll ignore the 3x for now. It is part of the answer. So we're going to have a 2x squared, and then instead of a negative 3x, we're going to have negative 5x plus 2x minus 5. We got to break it in half and factor each side. On the left of the break, we have an x in common, so we're left with 2x minus 5. On the right of the break, there's nothing in common, it's just a 1, so 1 doesn't change anything, but we got to write a 1. The stuff in the parentheses is the same, so that means we're doing it right. And 2x minus 5 is one of the factors. The leftovers are x plus 1. Slap them together like you do for dinner on leftover night. And then don't forget, there's a 3x out front. So this is the complete factorization. So D is the correct answer.